Okay, so we've only got an hour. This presentation usually takes an hour and a half to 3 hours, depending on how I format it. But what we have available to you after this is everything that I've done here in video format on the website. So just go ahead and head out there, if you want to try any of these features, and you can do them at a little slower pace, and again, rewind and fast forward and see how it was actually done. So for those of you who have been coming to these user groups for even a short amount of time, you've probably already met me. I've been with the company since SOLIDWORKS only had 3,000 users back in 1997. So I've really been privileged enough to watch this product grow from the cute little thing it was then to this really massive thing it is now. And you guys are the reason we're still here. So thank you very much for all that. So a lot of the things that I do is SOLIDWORKS here and when I'm off the clock. And the thing about it is I like to practice, I like to tinker, I like to do things, and this isn't really just a job. This is something that whether you're at a job getting paid or whether you're at home freelancing, SOLIDWORKS is really something that's great to access. This treehouse that we did a couple of years ago, well, this summer we put a garage door opener in it, fun stuff like that. But my 12 and 9-year-old daughters are figuring out how the world works and how to make things that did one thing do something else. And it happens a lot of times when it comes to just repurposing and trying to make something out of something. And it's really gratifying to see that work. So my 3D printer is a part of my life. I like to make parts. Scanning is getting to be a little bit more integral in that, the way things go. But I enjoy building stuff just to see the creative part of that. So that's really all about me in that particular case. So what we do a lot of is we create a lot of data for you. The YouTube channel is a huge part of GoEngineer. We're trying to get what's in our mind out there and accessible to you in as many ways as possible. So the not so unrealistic expectation of GoEngineer is to be the foremost resource of SOLIDWORKS in the entire world, which we're really doing a great job of. And the videos are a big part of that. I've got one that's about to drop here in about a week. This is an entry to a contest that I've won 2 years in a row at SOLIDWORKS World, so hopefully this will be a good one. So that's just a little taste of where that one goes. But I'll be going out here later this week. So later in this year, our world changed a lot as far as Decide Solutions was concerned. GoEngineer's offices looked like this. We had about 17 states for SOLIDWORKS and more when it comes to Stratus and other things. When Decide Solutions was purchased, we upped that to now 25 states. So we've got half the country covered with just SOLIDWORKS and on our way to the other half of it the way that it's going. So similar to what Jesse was saying there earlier is that what you've got is a larger resource pool. What it did for me personally is it took 4 of my jobs away and gave it to people that were better at those jobs, and now I get to focus on the other 4 jobs that I had. So it's really fun to be here and not be worried about those other tasks that are a little bit different. So anyway, life has been good when it comes to now being with GoEngineer. So we're going to buzz through this pretty quickly. I'm going to do a lot of live demonstration too, and I prefer to do it that way. So let's just jump right into what we're talking about. This year's data set was by Omax. It's an abrasive water jet machine. There's a lot of pieces and parts in it that really showcase some of the new functionality this year. So we're going to start with performance because we always start with performance. So the first thing that we do with performance in the last couple of releases now has been access to more of the resources of the computer. Last year we started harnessing the actual GPU of the video card instead of just using RAM. So there was 3D assembly performance that was pretty ratcheted up. That's full release with 2020. We call it beta, but it was this graphics pipeline thing that all you had to do is install your new drivers, and with OpenGL 4.6 that would open up this performance. Well, this year we added something called detailing mode. Now what this really comes down to is it's a lightweight way to open a drawing. Now when it comes down to what you need, you just need the drawing. That's the cool part. We've done things like this before. We've done things like detached drawings. For any of you that are familiar with the way to be able to save a drawing as this detached version, and then you can throw it over the fence to somebody to do detailing. And then when you get it back, you can open it and reattach it to the assembly or the part. It's kind of a way to offload those detailing tasks. With this, we're actually not making that happen. It's a dynamic way to open a file, and it didn't have to have been detached proactively in order to open it this way. So we can do about 90% of the things that you would do in a large drawing without actually having access to any of the data. The assembly, the parts, none of it has to be anywhere resident. So the speed is incredible, the line art is available, and I'm going to show you a bunch of the things that you can do with it. So we're going into SOLIDWORKS right now. What you're going to notice is when you do a file open, there's a little bit of a different interface down here, and I'll talk about that a little bit later, but it kind of simplifies when you select a different type of open what things can be done in those particular modes. So the one that I'm going to show you here is called detailing mode, and what I've got is a drawing, and the drawing has about 5,800 parts in the assembly. So pretty good size, right, for everybody out here. I'm going to say File Open. I'm going to click it and see how long this takes to open. Ready? 1, 2, 3. Usually don't get to 5. 4, 5. Done. So 5,000 part assembly. The drawing is open. This drawing has 6 tabs to it. It's there and everything is available to us for most tasks. So what you can't do, you can't make a bill of materials. You can't make a section view or make a view at all, really. You can still have to have the models to project views. Once those views are done, though, you can close the file, open it in this detailing mode, and you basically have everything available to you at this point. So when we're looking at what's around here, there's balloons that are already there, so of course moving details like that around is a pretty easy thing to do. For annotation purposes, if you utilize things like the design library, you'll be able to come in here and grab some annotations off this list and just drag those in as well. So there's a lot of different ways that you can utilize this. We've got a different list usage. Let's just grab that one. So I'll throw in a note there, format the note. It's the basic things, again, that you do that are the tedious detailing details, so to speak, as we would deal with. So with these other sheets that are there, we've got some views that are already done. So moving views, of course, is available. You just can't make the view because you need the resolve model to make those. But editing and moving the line art that's there, we're even taking a view like this one here, cutting it, and then maybe throwing it onto a different sheet. Adding a sheet's a necessary thing. So we'll click the Add Sheet tab, even reordering the sheets, dragging those tabs around, pretty easy to do. Once again, really hard to just demonstrate the fact that there's just no assembly even resolved in memory. So the performance is huge, but you just don't need access to it. So here we'll just go ahead and paste that view, piece of cake, put that in place. When you have the bills of materials and other things like that already there, what you're really doing is just manipulating what's there. So if you need to go ahead and add a balloon, the line art's there. So once again, you can add a balloon, participate with magnetic lines and things like that. And then the other things that are really the most common items, let's just go to this last page here, is the detailing itself. So of course, any button that's available is available. So when you go ahead and press Smart Dimension, of course, those are some pretty typical things. Now I see a lot of users not utilizing some of the cool things that are in the software. You might forget that there's these little widgets here, this little, let's not do that one, this little quick dimension. So when you actually put a dimension in here and it gives you this widget, you can hover it to one side or the other and it automatically locates things within the view. It's actually quite a cool thing and a lot of people don't utilize it to its fullest. The other thing that happens with features like this, especially when those in position, is you have access to this little thing that pops up, and a lot of people forget about it, but this tiny icon here is called the drawing palette or the detailing palette. And when you hover over that, it actually pops up the ability to fine-tune this particular selected annotation. So if you do something like a 4x, for example, or you're commonly doing something like the word typical, yeah, that looks pretty good. I fat-fingered that, but we're gonna go past it. The point that I wanted to show you on this is that those things are all available as well here. Now, last year we added a neat little check mark, simple little thing. But when you picked a bill of materials, if you didn't fill in the data, either manually or through PDM properties in uppercase text, you could force the entire bill of materials to be uppercase. Long lead in. We can now do that on dimensions. So regardless of how this dimension was created, if you pick on the dimension itself, you'll notice over here in the actual property manager, there's this all uppercase check mark. So once we go ahead and select that, it just simply uppercases everything that's in that particular dimension. Now with a mass selection, you can do that with everything as well. So pretty easy to deal with. Another thing that's kind of neat here, this is an unsung hero. This has been in SOLIDWORKS for about 20 years. It's called the Format Painter. I'm not even new, I just like to show it here because it can be done. This is an Excel or a Word-like thing. We got it from Microsoft Office, but what it allows you to do is pick something. So say pick this dimension, and then pick other dimensions to then push those properties to. So as I select these dimensions, we're going to get the resolution, we're going to get the tolerance that happens to be on this one, and it's basically a copy and paste of the properties themselves. So a lot of ways to deal with that. This is another forgotten one, revision clouds. You might not even use these, but this is a way to communicate directly on the 2D drawing. So whether you're drawing just a little rectangular thing on this one, or if you go ahead and actually put in a neat little revision cloud here with this one, where you can actually just do irregular, which is basically just dragging around. Ooh, that's not the one I want to do. I want to do one over here that's called that one, freehand. So as I go ahead and draw around it, you can put clouds around things. The point that I'm talking about with this is that these are the typical operations, and you don't even need a huge computer to do the detailing on a large assembly drawing anymore, which is kind of insane in its own right. One of the other, or two of the other main things that happens a lot of times when you're opening up a drawing and you sometimes have to pay the price to fully resolve it, is just simply to save it off as a PDF or a DXF or DWG file. So open, wait, just to be able to save it off as a different format. Well, because the line art is all here, I can do those types of save ases. So if I go ahead and hit the save as, first of all, it's going to yell at me and says, okay, do you want to save this resolving first, picking up any changes, or do you want to resolve it or save it without resolving? The cool thing about saving without resolving is that the next time you do open it with the full assembly in memory is it's going to keep all these changes that were made in this detailing mode. So there's no actual fear on this one. So we're going to save this one without resolving. The part of this that's interesting though is that all the file types are available. So if I want to go ahead and save a PDF or DWG, again, that line art being there, it's a pretty important thing. We're just going to do West Michigan on that one. And as you know, when you open up a PDF, it's going to give you a high resolution version of each of these. So in 5 seconds, I would have literally been able to open up this 5,500 part assembly drawing and then save it off as a DWG or a PDF file, and of course have all the little details, including all these little revision clouds and things that we just did. So this is something, bless you, that you're going to have to feel on files that you're more intimate with, because it's just something with performance, it's a perception. I can put a stopwatch on this and tell you how fast it is now, and you're going to say, oh great, but when you feel it faster on your own computers, when you're really going to get the picture on that one. Bless you. Could be me that's the problem, by the way. I already started sneezing when I started talking, so very, very probable. Okay, let's get back into something else. So we really added some incredible, I'll call them new things, but with old terms. Envelope being one of these things that's we've had some features called envelopes or some functionality referring to this, but this is a new take on this as well, and I'm going to demonstrate this in detail because I feel that it needs a little bit of setup. Envelopes have to do with creating features that are cross-related in parts and assemblies. Top-down is typically the term, but I want to avoid using top-down as the process that I'm showing. We're going to create inter-part relationships, but avoid the complexities and the performance hit that top-down gives you. Now on top of that, external relationships is a common thing that happens in top-down design, where one part related to another will have inter-part changes trickling through. And what we've added with this is actually under Tools and Options. If you go to External References, this tab right here, you're going to see that you actually have some new controls over when and where external relationships can be added, which can prevent them from accidentally being added. So to be very clear on this, when we're looking at what's happening down here, we're saying allow external relationships in a model. That's even a check mark. You can disable that and make it not accidentally happen. Now when it does happen, for the reference component, you can say to any other component or only the envelope component, which is the thing that I'm about to show you. The other part of this is that you can have it in the top level assembly or only in the same subassembly. So if you have a subassembly structure that's tiered several layers deep, you can prevent it from accidentally editing a part in a 7-level deep subassembly and having a top-down relationship to the top-level assembly. You can only keep it compartmentalized within the other feature tree of the top-down, or of that assembly proper. So the subassembly itself. Anyway, that's part of this. But what it really comes down to is a little bit of setup on creating relationships. So give me a couple seconds here and I'm going to show you some cool stuff. I got to set this up though first by showing you some files. We're going to go ahead and open up this Omax abrasive water jet. And in one subassembly we have this bracket part. Now in another subassembly that has to interface with this bracket part is a bunch of plumbing. We're going to open that up so I can show you exactly what it looks like. Once this assembly is fully open, you see that it's just plumbing work. It's fittings and it's tubes and it's nothing really exotic. Now I want to go ahead and open up the top level assembly that we're pulling this into, and I don't need to open up everything here, so I'm just going to open this up as lightweight. What's happening is that because of proper compartmentalization, we have several sub-assemblies in the top level assembly. But in order for one sub-assembly to interact with another, you have to set it to be flexible, which means its mates are now solving top level, and then create relationships in the top level assembly to either mate parts together or position them together, and that's the setup that we have here. So what we have is this plumbing subassembly, and then right here in the center we have this head that's got the bracket on it, and that's what that plumbing actually attaches to. So again, the setup here is that the only way for those two parts to interact with each other is to either take an evasive maneuver on the subassembly or build this as a top level assembly. Okay? Is everybody with me so far? I'm really making this to be a bleak story. It's not that bad, but we can avoid a lot of this stuff. Okay, so as a reminder, the subassembly here, our plumbing, looks like this. Pretty clean, pretty easy. At the top level assembly, we're going to use a button. The workflow is incredibly simple, but the result is awesome. It's a button that simply is called the envelope publisher. So if you're opening up and adding SOLIDWORKS 2020 to your computer, but you're using your previous buttons from 2019, make sure you find out what buttons are new in the What's New manual, because you might want to add those to the interface. In any event, this is how simple this is. When you pick Envelope Publisher, it's going to ask you to pick a component that's in one other subassembly, doesn't matter, and then pick destination subassemblies to push a referenceable version of that component into. Okay, so watch this. I'm going to pick the bracket right here on the middle subassembly, and I'm going to push that bracket into my plumbing subassembly, and I'm going to pick this from the feature tree just to make it clean. When I say add group, it will now push a referenceable version called an envelope of that bracket from the top level assembly into the plumbing assembly. Okay, wait for it. Okay, this is done. I'm going to say OK. Now here at the top level assembly, it appears as though nothing has happened. But when I toggle back over to the actual plumbing subassembly, check that out. We now have a transparent version of that bracket in this assembly. It represents where that bracket is in the assembly that the envelope was created. Sorry to error quote, but that's the only way I can do this one. There's a feature in the tree here that says what that envelope is and where it was generated so that it understands where that relationship came from. But what we have is a part that doesn't participate in mass properties, interference detections, bill of materials, or anything in this assembly other than being pickable and referenceable. So what I do with it is this. We go ahead and grab this edge and we simply roll it around, and I'm going to grab a little cylindrical edge here in the bottom of this part. We'll try and get it, and then I'm just going to make those concentric. We'll do profile center, that way they'll go together. Puts them together, we're in the subassembly, so mates work, right? Everything's great. And then after that's all said and done, the part is now referencing the envelope in its own working subassembly. Of course, when we toggle back over, because of full associativity, the subassembly's plumbing is all going to be touching the head in this assembly. Now if that head moves, the referenceable part moves, the envelope updates, the change in the subassembly structure of the plumbing changes. It all works. Okay, is that a little mind-blowing, or are you getting that one? And feel free to clap if you want to. That stuff drives me crazy. I love it. Yes, do you have a question?
I do.
Yeah.
When you put that into that subassembly, does that appear in the drawing?
It does not.
It is.
It's hidden by default. I think you can right-click and show it because there is a feature in the tree. But it's, I guess you could use it for even representing customer parts if you want to do that too. That's an interesting way. Now I'm going to show this to you another way, okay? This example here, it's cool, but I have another way that really will blow your mind about how simple and where a better way to use this is. And I'm going to open up an assembly. This assembly is 21 years old. It can legally drink. We made this in 1998 for the AutoFact convention, which used to be every other year, either Chicago or Detroit. You go and find out about computers and hardware and stuff. People are proactive, so we don't have conferences and trade shows for that anymore, so you come and do that here. But what I have is a bunch of sub-assemblies in a basic assembly line, and on this side of it I have a press, and that press is floating in the middle of space. Now I used to demonstrate creating a pedestal for this right here in the top-down assembly, but I'm going to use envelopes for this instead. So here we hit Envelope Publisher, and what I'm going to do is I'm going to push the floor into the subassembly. So here we click the floor, we'll pick a subassembly, which I'll grab from the feature tree because it's just easier to do, grab our press, and then say add to group. Now I could pick more subassemblies and push it into all of them simultaneously, or because I added a group, I can actually do a new pick and a new subassembly and make another selection without exiting the tool and going back in. That's the thing that groups does, and we use it in a lot of places. Here I'm just going to say OK. And if I go ahead now and look at this subassembly, so we'll just pick a part of it, we'll hit the little open button, but we'll grab the subassembly out of there instead, right? Boom. Now what we have is not just the press floating in space, but we have the floor there as well. And I should have opened up the press and showed you the floor wasn't there before, but just trust me there.
Can you do anything with that? I mean, can you array that envelope?
No. I don't know that. Okay, I'm going to go off grid here for a second.
Like with that previous part you had with the bracket or whatever.
Yeah.
There are instances where you might want to reference it to multiple locations.
It's working. The answer is yes, absolutely, 100%. I didn't try it, so I couldn't say yes, okay. But I couldn't think of a reason why it wouldn't work, so that's why we just tried it. Yes, it does. Let's see if it does, let's go 500. Let's see if it's just 2 envelopes then. It is just 2 envelopes. Okay, so that's all that becomes then. Good, okay, so for your purposes, yes, absolutely. So here's the reason that I did it here. The reason is because now I have it in the subassembly where I can edit a part, do some nice top-down relationships, and I'm just going to quickly bang this out. So I'm going to add a sketch. We're going to do an offset entities of this because I want to make a little pedestal. So a little 2 inches there interior. Beautiful. And then we'll just hit a basic extrude. You can fast track your extrude selections to an up to surface by just double picking any face, and it will then change it from a blind to an up to surface. Little bonus there. That's old. But then that creates a nice little pedestal. Okay, so now that we've got that done here, when I toggle back over to the other assembly, of course that's now supported. Here's what's going to blow your mind. I'm going to make a change. The actual part down here, the floor, is actually related to a plane. That's what gives it its position. I'm going to change that distance. And guess what? When you change the distance of the floor, magically right underneath it, guess what's there? Is that envelope is actually hidden there underneath it, sitting there. So when you move it and hit rebuild, of course the envelope has to rebuild, which means my floor drops, which means my extrude up to surface drops, and everything's great. So that's where I'm going to use it a lot, is these top-down relationships. But I don't have to do it here with 20 other sub-assemblies and all that junk. I can do it in the smaller assembly open and still get the same benefit. So that's envelopes. It's a long way to show that, but I thought it deserved enough at least to explain that out. It's the same that I needed to understand it, and if I'm having trouble with it, I kind of fear for users. I'm sorry. Yeah, it's perspective. It's totally perspective. Okay, next thing. We're going to talk about Streamline Workflow. This is really an open-ended thing because it's really just about making things easier to do, and it could be taking a feature we've had for a decade and just making it quicker and simpler. But this one here is actually adding something that's a little earth-shattering as well. And again, I've got to go deep into this one. I know this is a best of, but I want to show exactly what this thing does, and we've got the time to do that. So this is called flexible components. It is literally 4 parts that are flexible. So springs, bushings, boots, parts that are going to change orientation, position organically or just based on being compressed or expanded. It's great to show and it's very easy, but the problem I have with this is there's a bit of setup to it, and I feel that you need to understand the setup. So this is what we're actually talking about in this case. I'm going to open up a little file here for starters, this little head that we've got here. And the thing about this Omax abrasive water jet is that when you shoot water out of a nozzle, they try to keep it as laminar as possible, but it has a cone to it, right? So this thing has this pivoting axis mechanism that actually changes the angle of it so that you have a vertical edge hitting the outside of your cut part. So as you're moving this thing around, you'll see that this thing actually has this tremendous amount of pivot. So as it's cutting, it makes it a nice vertical edge. Your scrap has a big bevel to it, but your part has a vertical edge. It's fantastic stuff. That said, these parts over here, they actually have little boots over them. And when you take a look at those, the boots are there. And you can see that the boots kind of aren't in place. Again, we're in an instructional environment here, so I want you to see this. But everything we've ever drawn in SOLIDWORKS has always been a rigid body. It's just the way CAD works. You can make representations of springs and compressed and expanded, or you can make expression or representations of even O-rings expanded and contracted, but nobody does that usually. This is an element of realism that kind of lets us do this and allows the part to get updated. So I'm going to show you what happens, and I want to show you how it gets set up. So we're going to pick this part, I'm going to right click on it, and there's a button right there on the right click quick menu that says Make Part Flexible. Now the way the demo is set up is all I have to do is pick a little cylindrical face, and what we get is this auto magic update. So I want to go ahead and we're going to delete that one. Let me pick it one more time. That's the one I want. And when I say OK to this, what it will do is it will reposition that boot. It's going to blow your mind, right? I move it. The boot is not flexible now. This is one of the misnomers. It's not just going to be this rubbery, dynamically updating part, because that's a huge performance hit. But when I let go and I hit rebuild, you'll see that that boot changes, and it looks really, really good, right? It's got this twist to it. This part was made in a pretty snazzy way. There are 2 lines at the end, and then there are several 2-point splines on the inside, and those all allow this thing to twist. If you'd like to see this part on your own, I'll send it to you so you can deconstruct it. The problem with this is that you just don't take any part and just say pick here, make it flexible, and it does this thing. There is a setup to it, so this is incredibly important. I'm going to open up the sample files that actually come with 2020 so you can try this yourself. What we have are a spring, which is a seat assembly. This is where you actually make the top-down relationship, and I think that it's been demonstrated probably at least 4 times a year somewhere at this user group. Making that spring, and if you make the line longer and shorter, what you end up getting now is there is a line attached to the bottom of the blue part, and when we make it longer, that line gets longer, therefore the spring's entire coil length gets longer. In this respect, what we actually have for the spring, and the only top-down feature here, is actually this plane. And it's a little plane right here that when it's coincident to the blue part, if you move the blue part, the plane moves coincident, of course my spring gets bigger. But what makes this happen is that's the setup. Now we have to go ahead and use it elsewhere, and that's always where it's fallen apart. What we've done showing this is something that we've given at the user group all the time to be able to simulate this. The problem with this is that you can only use that one part in any one place in your assembly because it's going to have the same compression or expansion everywhere it is. That's where this flexible feature comes in. So what we have is the setup. We're going to now use this part in a completely different assembly. Complete complete avoidance usually when you have top-down features is using that part in another assembly. We're actually going exactly towards that. So I'm going to take this part and simply drag it from one window to another. Actually, let's grab it out of the feature tree. It's a little easier that way. So now I'm using a part with top-down relationships in a completely different assembly, and that's actually the purpose of this. So we're going to make this up slightly. I'm going to go ahead and take this bottom face here, and we're just going to make that coincident to the bottom face here. No big deal. And then I've got a little axis down the middle of this spring. Again, it's a sample file. So the axis there and the axis here will make those concentric. Okay, so what do we have now? We have a part attached to a bottom part. That's it, okay? Here's the magic. You now pick the part and say, make flexible. And what it does is it reveals the plane that is the top-down relationship in the seed assembly and allows you to re-reference it in the new assembly. We pick the new reference, and then that's what magically makes it happen. That's it. So when the setup is done, what you now have is one spring that you've created that you can now use and re-reference in any assembly you want. Now to take it one step further, I'm going to copy that spring. This is now 2 instances of the exact same spring, and it can be in a different compression state for each instance. There's nothing that you have to do to make that happen. That's actually some behind-the-scenes virtual component stuff. It's pretty wild stuff, actually. There's a couple ways you can see that happening, but this allows you to make one spring once. You can use it in any assembly as many number of times and re-reference any situation, and it can be in a completely different state of compression everywhere. So real easy to set up once you know this particular step.
Does that add a lot of data?
I don't see any more than any others. Springs in general do, but it's going to add more graphics than anything if you just have one part instanced 12 times versus 12 individual springs, which is what you had to do before to have them in different states or different top-down relationships. You couldn't do that in multiple places. Okay, so enough of that. Let's get into some more exciting stuff. That one there is pretty cool though. Okay, so after flexible components, remapping external relationships is just something I want to point out on that one. So with assembly mates, we've been doing mates constraint-based assembly for quite some time, and it leads to dynamic assembly motion. And recently there was the add of the quick mate toolbar. It's been 5+ years, but when you just simply pick 2 things on the screen and you get that little strip of mates available, that's a real quick way to get to things. Well, what we've done with the quick mate toolbar is enhanced it even further. So what you weren't getting before is you weren't getting things like the limit distance and the angle limit mates. You were getting angle and distance, but you weren't getting the limit mates for those. Those are now on the quick mate toolbar. The slot mate, when you pick a slot or when you pick a width, there's another pullout that gives you the positioning, the fine tuning. So whether it can sloppily go within the slot or whether it has to be centered or left or right justified, those are things that can happen during the mate. This thing here, this flip mate alignment, does anybody use this tool? I'm going to run through a little example of this. I've been running 2020 since July, getting ready for rollouts and now, and I had to do a project in 2019 the other day. It drove me insane that that wasn't popping up, and I'm going to show you why, because I was working 2020 mode, and you kind of don't know what you got until it's gone in some cases. So I want to talk about that. And then the width mate. You can actually right-click a width mate in the feature tree and flip mate alignments there. I don't know why it wasn't there before, but it's something that I wanted to point out. So let's quickly hit this assembly. What I've got is just a basic assembly set, and these little tools that I want to show you allow you to do less orienting of a part before you throw a mate on it. And I think everybody knows what I'm talking about there. When I want to throw a mate on something, what I will typically do is I will roll it into the closest position, right? So these 2 fasteners here, I'm going to roll that fastener until it's over 90 degrees, and then I know my coincident mate's going to go like that. Don't worry about that ever again. That's why it drove me nuts, because I got so happily used to it. So this is what it looks like. No picking prior to this. We're going to first select a cylindrical face here, and I'm going to control pick this slot. Now it understands a slot. When you make a slot with a sketch, it's not just 2 lines and 2 arcs that are tangent. It knows it is a slot. So when you pick it, it actually pops up with not only a slot mate on there, but there's a cam mate there too. That's one I didn't even talk about. But you can pick slot mate directly from that. Now when you do that, it's going to position the component, but then it gives you that little fly out there that says, do you want to center it, or do you want it to be free? You go ahead and click that and it'll put it in position. So that's the little benefit of that. Now I'm going to take this face here and this face here, and I like to use the profile center mate. That's a very, very important one to me. When I throw this one in place, I don't know why my mates aren't animating, by the way, they should be. But when I say OK to this, what you now have is this quick flip up under your cursor where you can just go boop, and it'll flip that mate for you. So don't worry about it. It's always going to position it and present itself for you. So even better, let's do this one. The width mate works. So if I have convenient access to pick a bunch of faces, so let's just go ahead and say, yeah, we'll take these faces here. So I got a couple of faces there. We got a face on top, face on bottom. I'm picking 4 faces, random. I've never put any mind share into what's the tab faces, what's the width faces. I've said that here before. Just pick 4 faces, it'll sort it out. When you hit width, it'll put it width, everything's great. And 2 things I can do here. First of all, granular, we can say centered, and then when we say okay to it, now we can flip it too. Boom. That's easy enough. So now that's done. Throw a quick coincident, concentric, and now everything is good there. So the last one that I want to do on this one, we got this hinge, let's make him flexible. So I got a hinge that's moving around up here. Pick a couple of flat faces arbitrarily, and again, you have distance and angle, but then there's also the limit versions of those. And what that means is you fill out 3 dimensions. So here I'm filling out where it's positioned now, 45, and then I'm going to fill out the maximum, which will be 90, and then the minimum, which will be 0, all right there on the pop-up. And then again, I can flip that mate if I want to. If you go away from it, it just flies away, you ignore it. But what I now have is a mate that hard hits on the top and on the bottom instead of having some sort of slop or 360 degrees on that. So that's really it. It's just really quick little pop-up enhancements. I did say, oh, one more thing. Whether you do this inside of the feature tree or whether you do it using, I like to do it using breadcrumbs a lot, but here's the width mate. I'm going to right click on the width mate and there is that flip mate alignment on the right click. Again, it wasn't there, you might have been looking for it. To me, those are discontinuities in the system and those are something that the developers fix quickly. That's this way here, it has to be that way everywhere, otherwise things just don't work the same. Okay, looking good. Do you guys do patterns in your assemblies? Here they do. If you're from Fog Filler, then I shouldn't have asked that question because that's just what that is it's just a, you know, just a revolver of filling. So patterns are a big deal, and I find a lot of people underutilize patterns, sometimes because they don't know what power they actually have. Many times when I'm doing patterns, I'm at the part level, understanding that a feature pattern can be leveraged in the assembly. Just know that that can be. And one of the things that's enhanced in this one is that type of functionality related to the hole wizard. So I'll get into that. Mirroring is technically a patterning function. So we roll those into the exact same position. So let's just get into this assembly here. I might as well show everything live. I think I've got enough time in just what I've got planned here. So we'll throw a couple of the low-hanging fruits on this one. In this box in the middle, this is really a particularly important one because the pattern that I want to talk about right now isn't just a typical hole pattern. It's actually the 3D hole pattern. And for those of you who use the hole wizard, you might not realize, you might not, but I find that you don't know what you don't know, so I don't want to just assume anything. You might not realize that if you pre-select a face in a part and then hit the hole wizard, it makes a 2D sketch, but if you don't pre-select the face, it'll make a 3D sketch. 3D sketches are cool because you can put points coincident to any face and it will go perpendicular to opposing faces, or if you have a shaft, it'll actually go perpendicular normal to that shaft at any point. Well, in this particular situation, what we have is a fastener, and this fastener is in a hole pattern, but that hole pattern happens to be a 3D hole wizard pattern. So what you do is you make the part level hole pattern, and then you put one fastener in the hole as an assembly, then you can pattern the rest using the parts pattern to drive it. So this part has the holes. What I'm going to do is use something called a pattern-driven pattern. It's one of my favorite things all time because the pattern-driven pattern allows you to do basic feature patterns, but then really amplify the amount of components, locations, and quantities, not only saving yourself mates, but also accuracy and quantity counts. So here's pattern-driven pattern. When you do the pattern-driven pattern, you're picking 2 things. You're picking the components you want to pattern, which is going to be my fastener, and then you're going to go ahead and pick any instance of the driving pattern feature. So let's go ahead and pick any hole. Okay, 2 things. 2 things that are just blown up right now. First of all, I didn't pay any attention to the original hole of the hole pattern. Therefore, when we're actually referencing feature patterns, we're referencing spacings and direction and how many. So that was probably started over here, didn't really pay attention to it, and I put a fastener in here, which means the hole pattern is going to the left. None of this is a big deal anymore, by the way. There's this button over here that a lot of people miss called Select Seed Position. What that allows you to do is actually say, I put the fastener in the wrong hole, so sorry, but let me tell you what hole it's in and then figure it out for me. So what I basically do is I say, okay, there's little magenta dots that are out there. You pick the one that's actually the seed, and then it will sort out the spacings and directions and everything from there instead of from the original. So no more forethought there. The other thing is this one that says either align the fastener to the holes or align it to the seed. Now it's aligned to the holes, so you can see that the fasteners are actually opposing each other 90 degrees. If you say align to seed, they're all going to be aligned in the exact same direction. So those are the 2 things that are over there that are pretty cool, is just using these patterns for 3D hole patterns. And then if you change the part pattern, quantity and spacing, the part pattern changes, the bill of material changes, everything is associative. So really, for me, I have to have everything driven, so a change made in one place changes everything else. It's just the best way to work. One more I just want to show here. I'm going to do mirroring real quick. Mirroring is a great way also to capture what you have, but you don't just take existing parts and mirror them. You have some choices if you want left-hand, right-hand versions. Fasteners, of course, you wouldn't because you don't want left-hand threads, but for parts that are physically mirrored, you don't have to remodel those either. So to mirror components in an assembly, it really just requires a plane and then selection of a sub-assembly or parts or any really combination of those. I'm just going to pre-select. And when you pick on mirror components, it lets you know what you've selected, an opportunity to pick more, and then when you click next, you'll get a nice preview. The main things that were changed here is two things. First of all, the previews of these little positional things, the icons on those or the hieroglyphics are a little bit more understandable, so that when you're clicking on those for part position, you can understand how it's actually related to the original. I should probably show you the original so you understand what that's doing. Right, left and right, up and bottom, and this and that. The other part, way more critical, that you're going to find interesting here, is that the mirroring type has always been relegated to two things, this center of mass or this bounding box. And for non-symmetrical parts, this is not good, because the center of mass of a bounding box doesn't really show you where holes are or where any features are. The component origin is the new one here, and that actually gives you a much better result. So if you take a look at what's happening over here, there's not a big difference. If I say center of mass, it shifts over to the right a little bit. If I say component origin, it shifts just a little bit, because that's a much more accurate point to mirror something around than it would be the actual bounding box, which is just a big square encompassing the data. You could have all your data over here and then a wire going out this far. This is your bounding box. Center of mass is over here, but the box itself is encompassing the part. So that one there, being able to mirror throughout the origin, is just a big deal there as well. So if you fought that one, you'll understand that. If not, you're just no more now. Okay, we are coming up on 35 minutes after, so let's get into, I had a video to play that, but I like live again. Markup. We started talking about this one in 2019, but there were two huge flaws, and both of them have been addressed in this. And when I say flaws, they weren't bugs, they were just limitations in that case. So markup is the ability to actually do markup directly on your files. Last year when we debuted this one, it was in 3D parts and 3D assemblies only, and it required a touchscreen computer. And both of those are addressed in this release. Both of those are great. So let me just show you a video because I don't have a touchscreen computer. So what we got going on right now is a tablet. And with a tablet, you can have this little right-hand area here. It's a big, thick area to get right mouse menus and shortcut menus and other things selected. What he's doing is he's just using a stylus, and this could be a Wacom tablet, this could be SOLIDWORKS in the cloud, running off of mysolidworks.com on something that's touchscreen. Really, it's just the hardware. But a lot of people these days don't proactively buy touchscreen hardware, they just get it as an and then. So you can do different things with it. And where we're going with this is trying to store this information directly in the file. So it sits in the feature tree, it's consumable by anybody, whether you have created the markups or not, and you can kick these off as image files or as PDFs. So in this particular case, exporting, clicking them, getting highlights and tooltips are great things. Now what he's going to end up with this one is those two limitations that are addressed. First of all, 2D drawings, because frankly 2D drawings are where anybody with a red pencil is going to go ahead and do the markup anyway, traditionally. So that's one that's an important part. And then once he gets done doing this a little bit, he's going to go ahead and put the pen down and actually grab the mouse. Now I know it's big muscle, little muscle stuff. That's really why artistic people like to use a pencil versus a mouse, because of the way it moves. But in any event, we didn't want to limit it to the kind of people that could use it just because of the hardware. So anyway, he's going to put that pencil down and just prove to you that we can do it elsewhere. So you're picking markup on the markup tool tab. You pick the color, the thickness of the line, and then you just go to town and draw things. And that'll live directly on the files. 3D part, 3D assembly, and 2D drawing. All of those work. So, kind of fun.
Why did they give you keyboard options?
I don't know. Oh, say that again. Why do they give you keyboard options on the side of the tablet?
No, markup.
It is keyboard options. Actually, I don't think I mentioned that. There's one more part of that. I want to get into the video again in a second here just to show you where this was. There is buttons that pop up. No, this is markup, I'm sorry. Markup's different than sketching. Sketching has keyboards that pop up. So instead of having to draw things on screen or actually having a virtual keyboard of the tablet, there's some numbers that actually pop up on a virtual keyboard on it.
Oh, I was just thinking, just using your regular keyboard to add just rough notes.
That's just the notes tool then. Yeah, that's just putting in a note. So this is more of the guy that's doing the quick slash that out, change this. You know, it's basically the red pencil person that's been doing it since the early days of the drafting board. So, yep. Okay, repair fillets. Who has ever had a broken fillet? Sorry, put your hands down, stop that. If you haven't had a broken fillet, you don't deserve to be at this user group, to be honest with you. Everybody has experienced it through no fault of your own. There have been a variety of ways to attempt to make broken features repair themselves. And in some cases successful, in some cases it's just too difficult to do. This one is awesome, but I also, again, want you to know how it works, because then you know how to help yourself. This is a situation where, because of a design change that's necessary, we're going to inject a problem into this. And a lot of people will avoid a design change to avoid a problem they know is coming, right? So I don't want people to engineer that way. I want you to make the change you need to make and not avoid it because the software is going to hassle you for trying to do something you need to do. Here is the change. What we have is a part, and this part is completely happy with itself, but we want to make two configurations of it. And to do that, what I have is a part that is basically made of an extrusion, one feature. We added some holes to it, and then we put some fillets on all the inside sharp edges. Well, to make this a little bit more flexible, I'm going to roll back a little bit, and I'm going to separate the cut from the extrude. So now we have one that's either got the screen or doesn't have the screen. Okay, this is how this is going to work. I need to edit the first feature, and instead of using the entire sketch, we're going to go ahead and use some profile selection here when we use our contours, and I'm just going to go ahead and extrude it to regular thickness. Now with the rollback bar in place, we're going to use that same sketch one more time, and I'm going to go ahead and use that sketch to make a cut. So now with our cut, what I want to do on this one is not use the entire sketch, but I actually just want to use the profiles on the inside. So that's where contour select works really nice. And we're going to go ahead and reverse the direction. Okay, so now what we have is this two-featured part. Well, do you know what that does? Some of you know exactly what I just did. I broke all the fillets. Guess what? The holes still work. Why do the holes still work? Because they're related to the sketch, not to the part. Okay, but the fillets are dead on arrival. Saw it coming. And the internal reason is because when you pick a face or when you pick an edge, there's an internal ID or a name. And that name is how it knows how two faces mate together, what faces go, and what edge you've picked. And when you reorder the part or rechange the modeling structure, you've changed the naming structure. That's why importing is also tough to deal with, because they're random names. Okay, when you edit a broken fillet, we've been giving you this for a long time, which is the dead silhouettes of the problemed areas. So at least you have some sort of semblance of where my problem is and how do I fix it, something similar. If those edges are in the same place, in other words, if I didn't make that cut and then change the offset thickness and then have my fillets break and then realize this, I have no problem fixing this. The fillets are in the same edge. All I have to do is right click in this box and say repair all missing fillets, and then they all magically snap right back in. So if you know that that's going to happen and you need to change this offset thickness, just repair your fillets first and then go tweak that sketch and update it so that maybe there's a little thicker rib to that side. If those edges are then offset, it can't find the home again. So just knowing that the order is important is enough to just do it. And then John looked at that and said, but yeah, why do I have to right click though? Can't they just do that for us? Okay, he's really unsatisfiable, by the way. John's tough. It's pretty awesome, but it just fell that far short to really impress him. That's okay. He's what really scrutinizes software and makes it really cool. Problems with fillets. There's also a similar thing that a lot of people I see run into with surfacing. And I'm not going to show you a big surfacing demo. I use surfacing where appropriate, typically to hybrid my part, maybe to cut a face, something to trim, or to extract data from another part. I only need pieces, so I only need a few surfaces. Otherwise, I don't really do hardcore surface modeling. But copying faces and offsetting faces is a pretty common task. So I'm going to show you a scenario here that we run into quite often, and again, a really elegant way to deal with this. So we have this little cover, and this cover has got an internal pocket, and those are the things that always make me nervous when I'm about to offset surfaces. So when I go into my surfacing tool right here, I'm going to pick the surface out of the tree, and we're going to use our offset surface tool. Little bonus instruction here. Does anybody know that we don't have a copy surface tool? You know that? 25 years, we do not have a button that says copy surface. However, if you pick offset surface and you set it to 0, it becomes copy surface. I don't know why we don't have a button for it. I don't know. Anyway, it's funny. It's just funny to talk about, frankly. I don't want the button. It takes the story away. Okay, so I'm going to bump this offset surface up to 5 millimeters, and we're going to the outside. And here we're going to set up a situation where, because of the offset, we now have self-intersecting collapsing faces, right? Probably what you expected. Well, usually what you have to do is pick all the faces you want and then get told that you have a problem, and then you have to figure out where that problem is, and that's just tough. So now what happens is this. Now we got a preview, so when you get a preview, you're guaranteed to get results, right? Not quite. When you say okay, and you're like, yeah, it's gonna work. Now it says, cannot offset the surfaces. But like that fillet, after I wait a few seconds here, it identifies the ones it can't do and the ones it can do, and it lets you remove them from the selection immediately. Right click, remove all failing faces. So instead of you deselecting, hoping it works the next time, it actually just figures it out. So now that being said, what it actually does in this particular case is it offsets, in this case, 2 surfaces, and we end up on the inside with just this tiny little overlap, right, just right there. But if you know enough about this, you can just say trim and pick your big surfaces, and then all you gotta do is either pick the pieces you wanna keep or pick the pieces that you wanna remove. So here we're just gonna go ahead and pick the chunks to keep, and then what goes away is that little overlapping sliver of junk. Oops, sorry, green. And then it just kind of gets rid of that and knits it all together to one nice trim. So those 2 features just in that order. The offsetting and collapsing, that's just a known, you got to deal with it based on geometric condition, which is our developer's favorite throw for an error message when they just don't know what it actually means. I don't know. They're ingenious, so I don't bag on them too much. I've never written a line of code and I get to show it, so I guess I should be nicer. But when we hear the stuff that really hits, I like to let the developers know. So we're coming up in the World Conference at the end of January, so that's my chance to talk to them. Okay, still making 2D drawings? Everybody's making those? I'm assuming you're not going to model-based definition yet. I'll work on you for the next 10 or 12 years on that one. 2D drawings. There was only really a couple of significant things that I did want to show on this one. So with 2D drawings, all uppercase applies to those dimensions. There are settings in tools and options that do what I did when I picked the dimension and checked that check mark in the property manager. You can just set it under tools and options in your dimension standard, just as that's the way it always is. Always uppercase no matter how you type it. It's not so bad to control when you type it, but when you have data cards from PDM systems that are filling properties or filling notes, you don't have control over necessarily how everybody else types it, so that's why those are important. A couple things I will show here. Scaling the drawing is a little quicker, and this thing called chain dimensions I definitely want to hit. And then alternate position view. Anybody use that in assemblies? We have it now for parts. I'm going to let that marinate a bit. Alternate position view for a part file. Okay. I'm not kidding, by the way. So I've got this drawing that I want to open. I didn't open that way for some reason. So we're just going to go ahead and open this guy up. Alternate position view for parts. Again, let that soak in. I'm not kidding. So 2 things that I want to show on this view. We have added this access to dimensions and to your scale features in this lower right hand corner for a while. Actually, it's a little scale selector in this corner. That has been hard-coded since the beginning of time, and in this version, it's no longer hard-coded. You can actually change it based on a text file, the same way that you change your dimensions with that text callout format.txt for your holes. There is a text file, and I've got a hyperlink to it. It's in your program file. So if you look at my hyperlink, here, it is C:\program files, SolidWorks, and then it's relatable to the region. So it's under SolidWorks, language, English, and then there's going to be your drawing scale.txt file. When you open this up, you can add anything that you want per standard, so ASME, ANSI, ISO, and so on. So if you needed from a selectable region here, I always use 5000 to 1 because I make really big stuff. That'll now be on that pick list. Okay? I can't change it now and save it because this file's in use and SolidWorks is running and it won't let you save over a file that's being referenced. But that's how you go ahead and change that. Once that's done, this pull-up menu is going to be yours. The other thing about it is it's very quick to change these scales now. You can type it in as, say, like a 4/3 or a 4:3 and just say OK, and it's going to do it quickly. It doesn't have to be on a list. You don't have to do these elaborate selections over in the property manager. So a couple of interesting things there. Okay, let me get that scale back down just a little bit. Oh, it's a little large at this point. Let's go 3 to 2 is probably going to be okay. Oops, that's the other direction. All right, I want to go just a little lower here to show you some dimensions. There we go. Let's go half. Okay, so I want to throw a little detail view up here for a second. I'm going to do a little detail of this bottom section here. There's a new dimensioning functionality. Smart Dimensions works for most everything. But when you got to do something odd like an ordinate dimension, or in this case baseline and chain dimensions, they have a bit of a different behavior. Excuse me a second. When you go ahead and grab your dimension tool, you can right click on it now, and if you go to other dimensions, more dimensions, we now have this one here that's actually called baseline. Now baseline and chain dimension are two that have been, baseline's been there for a while, but chain is the one that's added, and they have very simple. What's that? Are we done? Oh man, already? Killing me. I'm gonna show this anyways. Chain means you can select here, and then here, and then here, and then here, and it just keeps adding dimensions to the chain. So pretty cool. You can right click on that and you can actually switch it to a baseline, and it will just switch the stack. So neat way to do that. All right, Andrew cut me off. I'm gonna see what I'm missing. Structure system, ask us about this if you make big weldments. We have really good videos on this. This entire structure system was made using this seed file. One sketch, 3 points, 1 line, 4 planes. That's all it took to make all that. All right, I know he's cutting me off. So 3D printing is a big deal. If you are into augmented reality, excuse me, we have a new thing in eDrawings, which is virtual reality. You can get an HTC Vive headset. They're about 500 bucks. We usually have one running here, actually. You guys see that more than anything. I reference this user group when I tell other user groups about it. So eDrawings is really getting high quality when it comes to graphics. Performance is huge. We're using the video graphics processor, and it even shows depth, so you can pan through and into glass and things like that. What I wanted to get to at the end here was SOLIDWORKS Cell. This is not part of SOLIDWORKS. It's a brand new thing for us. But for anybody that's been asking for online configurators, this is awesome. I can literally upload a file. I can add a few different materials to one, maybe different configurations to another, and it will calculate hundreds, thousands, or millions of permutations automatically for you. You don't have to do a design table like we did before. But what it gets to, I'll play this little video here, talking about the water jet that's moving. This is the SOLIDWORKS Cell interface. So it's built into web pages. I've got a GoEngineer page I'll let you go ahead and pull up at the end of this. But you can pick different configurable materials, different configurable positions, as it'll be with the doors. And these interfaces are super easy to put together. So I did one of my tree house of a little configurable rocket that I've created, chairs, but it uses augmented reality. So what happens is after you do this configuration, if you're looking at it on a phone or looking at it on a tablet, what you can basically do is just hit a single button. It's right here in this interface. I'll show you in a second. When you click on the AR button, it enables you to take your phone, point at any horizontal surface within the room, no more QR codes or targets, and what it will do is it will throw a full-size version of that assembly right there in the room. So if you want to try this at the next step here, I've got a slide that's going to show you the web address that you can try this, but what you're doing is repositioning it in the room, and a lot of our 3D printer sales guys are using this to actually show what their Fortis machines are going to look like directly in somebody's office. So it's amazing stuff. Really easy to do, but the result of that augmented reality is pretty cool. So if you go to goengineer.com/AR, you're going to see 8 examples that we have there. So we've got some 3D printers, there's a chair, a watch, a backpack, some other things. So goengineer.com/AR, and that gets you to a page where all you got to do is click it and run it. Anybody that wants to see this in the break there, just come see me and I'll show it to you on my phone as well. But it's a really incredible way to be able to immerse a customer and really bridge reality and this fake digital stuff together. And that's where augmented reality is different than virtual reality, which is completely fake. Okay, I knew I was doing pretty good on time there. Question?
You said it was part of SOLIDWORKS Cell.
SOLIDWORKS Cell, it's a new offering. Yeah, so it's just something for people who need that. Yeah, it's its own thing. Yep.
So is that like
It's something that you just purchase as a service. It's like getting Composer or Simulation or some other tool. Yeah. And then follow us. Like I said, we're putting out a ton of stuff, so we're posting it on Twitter and all the social medias. I'm really active on LinkedIn. LinkedIn is where you avoid grandma's photos and all the garbage. You know, get out of Twitter, because Twitter, we're just talking. 11 of us are talking to each other on Twitter. There's nobody else watching us on Twitter. So, but hit us on LinkedIn or check us out on Facebook, or hit the website. Our YouTube channel is incredibly packed. We're putting dozens of videos up on a daily basis. It's just incredible. So all of us get tasked with that, and it's pretty fun to be able to add to that library. So I'll hang around for questions afterwards here. I don't want to miss the ice cream, but I want to thank everybody for just taking some time and hanging with me for an hour. So thanks a lot. Appreciate it.